All right, welcome to the Explainer. Today we are diving headfirst into one of the most fundamental, most critical tools in your entire Unity toolbox, the get component method. Honestly, this one little command, it's the key. It's the secret sauce that lets all the different pieces of your game objects actually talk to each other and, make your game feel alive. And to show you what I mean, we're going to build this, a simple but super effective visual feedback system. You see how the car turns green when it grabs the package and then snaps back to blue when it makes the delivery? That might seem like a small detail, but believe me, that kind of instant, clear feedback is what separates a game that feels good from one that feels clunky. And by the end of this explainer, you'll know exactly how to build this from the ground up, and I guarantee you'll use this skill in pretty much every single game you make from here on out. So here's our game plan. We're going to break it all down into 6 easy steps. We'll start with the why, our goal, then cover the theory of what components even are. After that, we'll hop into the code, set up our script, write the get component logic, and then we're going to hit a roadblock. We'll take a quick detour to fix a really common bug, and then finally, we'll add that last little bit of polish to make it all look great. Okay, section 1. Let's really zero in on our goal here. The main objective is to give the player an unmistakable sign that, yep, you've got the package. So, why are we messing with the color? Why not do something else? Well, we could have 2 separate images, right? A blue car sprite and a green car sprite, and just swap them out. But what if you don't have a green car sprite? As a programmer, you don't want to be stuck waiting for an artist to create a new asset for every single visual state. That's just not practical. So instead, we're going to use a much more clever and flexible approach. We're going to tint the original sprite's color using just a few lines of code. It's a fantastic programmer's workaround that saves a ton of time and requires 0 extra art. And this right here, this is our target. If you look at any object in Unity that displays a 2D image, it's going to have this thing called a sprite renderer component. And on that component is this little color property. See it? By default, it's set to pure white, which basically means no tint, show the original colors. But if we click that and change it to green, bam, the car gets a green overlay. Our entire mission is to get our script to reach over and change this exact color property automatically when we play the game. But hold on. To make our script control that sprite renderer, we need to take one tiny step back and understand the big idea behind how Unity works. And that big idea is the component system. It is the absolute foundation of everything you will ever build in Unity. So think of a game object, like our car, as just an empty box. Seriously, on its own, it does absolutely nothing. It's just a name and a location in your game world. Components are the functional pieces you attach to that box to give it abilities. The sprite renderer component makes it visible. If we wanted it to have physics and bump into things, we'd add a rigid body component. And guess what? Our own scripts, like the delivery script we're writing, are also components that we attach to add custom behavior. So, okay, here is the light bulb moment. Our delivery script and the sprite renderer are 2 completely separate components, just chilling on the same game object. They're neighbors, but they don't know each other exist. So how in the world do they communicate? That's where get component comes in. It's the bridge. It's a command we use from our script that basically shouts, hey, look on this exact same game object I'm attached to, find the component called sprite renderer, and give me a direct line to it so I can start telling it what to do. All right, enough theory. Let's get our hands dirty. We're going to jump into our delivery script and start setting up the variables we'll need to make this all happen. We need a place to store our colors and a place to hold on to that sprite renderer. First things first, we need to decide what colors we want to use. So we'll declare 2 variables of type color32. One we'll call hasPackageColor and the other noPackageColor. Now, see that little serialized field thing I put above them? That is one of the most useful tricks in Unity. It tells the editor, hey, even though this variable is private, I want you to show it in the inspector. This lets us pick our colors visually with a nice color wheel, which is way better than trying to guess RGB values in code. And you might be asking, why color 32? I've seen a color type before. And you're right, but the standard color type uses float values from 0 to 1, which can be a little weird to work with. Color 32, on the other hand, uses the good old 0 to 255 scale for red, green, blue, and importantly, alpha, or transparency. This is the exact same system that tools like Photoshop use, so it just feels a lot more natural for artists and programmers alike. The 32, by the way, just refers to the 32 bits of computer memory it takes to store all that color info. Okay, next up, we need a variable that can actually hold a reference to the sprite renderer component once we find it. So we'll declare a new variable. The type is sprite renderer with a capital S and R. That's the official name of the component class. Then we give it a name, sprite renderer, with a lowercase s. This is a super common convention, and it's really helpful to keep your code clean and distinguish between the concept of a component and your specific variable for it. Awesome. Our variables are all set up and ready to go. Now it's time for the main event. Let's actually write the code that calls getComponent, grabs that sprite renderer, and uses it to change our car's color. We're going to do this inside the start method. Now, start is a special Unity function. It gets called automatically one time and one time only right at the very beginning when your object first appears in the game. It's the perfect place for setup work. And the line of code is beautiful in its simplicity. Sprite renderer equals getComponent, sprite renderer, semicolon. This translates to, hey Unity, as soon as the game starts, find the sprite renderer component on this game object and store a permanent link to it in my sprite renderer variable. Now, what we just did, that is an absolutely critical performance concept you need to burn into your brain. It's called caching. See, calling getComponent isn't free. It takes a tiny bit of processing power for Unity to search for the component. It's kind of like asking your phone for directions. If you ask for the same directions every single second while you're driving, you're going to waste a lot of battery and time. By doing it just once in start and saving the result, we're essentially writing the directions down on a piece of paper. From that point on, whenever we need the sprite renderer, we just glance at our paper. It's instant. No more searching. And here is the payoff for all that setup. Down inside our onTriggerEnter2D method, which is what detects the collisions, we can finally use our cached variable. Look how clean this is. SpriteRenderer.color equals hasPackageColor. We're using our stored reference, using the dot to access its color property, and simply assigning it the color we picked in the inspector. Then, when we deliver the package, we do the exact same thing to set it back to the noPackageColor. That's it. All that setup makes the actual logic incredibly simple and efficient. So let's just quickly recap this workflow, because you're going to be using this pattern over and over and over again. It's a simple three-step dance. Step 1, declare a variable of the right component type. Step 2, in the start method, cache the reference to that component using getComponent. And step 3, use that cached variable anywhere else in your script to control its properties. Declare, cache, use. That is the fundamental pattern for making components talk to each other in Unity. Okay, the code is written. We've gone into the inspector and picked our pretty green and blue colors. In theory, everything should work perfectly. So let's hit that play button and see our masterpiece in action. And wait a minute. Uh-oh. That was definitely not supposed to happen. The code is working, right? We drove over the package and the trigger fired. But instead of turning a nice shade of green, our car just vanished. Poof, gone. This is one of those moments that can drive new developers crazy, but it's an absolutely fantastic learning opportunity. So what on earth could make our car turn completely invisible? The villain of our story is right here, hiding in plain sight inside the color picker itself. Remember how we said color 32 has 4 values? Red, green, blue, and that last one, alpha? Well, alpha controls transparency. An alpha of 255 is fully opaque. You can see it perfectly. An alpha of 0 is completely transparent. It's invisible. And it turns out, when we picked our color, we forgot to check the alpha slider, and it was all the way down at 0. And the good news is, the fix is about as easy as it gets. All you have to do is click back on your color properties in the inspector, both the hasPackageColor and noPackageColor, and find that A slider for alpha. Just drag that sucker all the way to the right to the max value of 255. Do that for both colors, and you're golden. Now our car will be fully opaque when we change its color. All right, the bug is squashed. Our car is now changing colors exactly as we wanted. We could stop here, but let's add one final tiny touch of polish. Because good game design is often about making things feel cohesive. And right now, there's one little visual detail we can improve. Think about the visual story. Before, when we pick up the package, our car turns green. But the package itself is, well, it's this original brown color. It works mechanically, but it doesn't quite connect. A much cleaner solution is to just go into our package prefab and also tint its sprite renderer to that same green color. Now it feels right. The green package makes the car turn green, it tells a clearer story to the player, and that's what polish is all about. So there you have it. You have completely mastered the workflow for getting a script to talk to and control a sprite renderer component. But here's the real magic. The technique you just learned is universal. The exact same pattern, declare, cache, use, applies to everything. Want to make the car faster? You'll get component rigid body 2D and change its velocity. Want to trigger a cool particle effect? You'll get component particle system and tell it to play. How about playing a sound? You'll get component audio source and call its play method. You now hold the key to controlling any component on any game object. The only question left is, what will you control next?